Raise your hands as far as you can. Higher, higher, higher. Still 2 more centimeters to go. Oh, hope I don't break anything. And then down. Don't hit your neighbor.
I really hope that you feel better now, because I was I was tired already. I have to accept that. It was very challenging really to have 34 presentations in 4 hours, perhaps, something like that. Nevertheless, it is of interest. I would like to say good evening from my side, and I would like to try to present in less than 8 minutes what we are trying to do inside in this project, which has as an acronym SMART-CHP, which stands for a very long title that reads Demonstration of a Small-Scale Mobile Agricultural Residue Gasification Unit for Decentralized Combined Heat and Power Production. The coordinating beneficiary, it is our university, Aristotle University in Thessaloniki, Greece, having 2 laboratories involved, one from mechanical engineering and one from chemical engineering, and then having as associated beneficiaries 2 companies in the northern part of Greece. I will show you later on the geographical details that they were asked. First of all, I would like to say a few words about the motivation. Why? Why do we decide, and what is it that we want to do? Biomass, as it was already discussed, I think, is a very important renewable energy source. And in particular, as regards Europe, it accounts for something like 2/3 of the already used renewable energies in the continent. And of course, most of it comes from biomass and waste and a lot of wood and other. The problem with biomass is that it is scattered all around. So if you want to do something which has a good efficiency, it has to be big, it has to be central, and then you have to deal with all the logistics that are related with it. However, you are leaving lots of biomass scattered in the rural areas, actually lost there. So the best way to do it, or at least one of the good ways to do it, is to build decentralized units that could be also mobile. So you go where the biomass is. You don't wait for the biomass to come to you. And then to do what with biomass? Probably the most interesting and the most challenging thing that one can do with biomass is to produce electricity. And how to produce electricity? The best way, again, using conventional techniques, is to use an internal combustion engine coupled to a generator. So use a genset. And this is what we are trying to do. However, feeding an internal combustion engine with wood or biomass in general is not possible. Therefore, our idea was really to go on and to use gasification as a technique. For those who are not fully familiar with the term, gasification is a simple process, chemical process, where you feed biomass with hot air, sometimes also adding vapor to it, hot air much lower than what it is stoichiometrically necessary in order to combust biomass. You should not burn it. You just gasify it at very low airflows. And this leads to the production of a gas, which is called producer gas, syngas, which basically consists of carbon monoxide and hydrogen. And then this gas, after of course it is thoroughly cleaned, it can be used and it can be burned in an internal combustion engine as if it was, for example, methane or liquefied petroleum gas, whatever other gaseous combustible that you can think of. So this is what we're trying to do here, and of course this is not a new technique. This has been used during the Second World War extensively, when there was a big lack of liquid fuels. Many cars have been operated on this process, on this particular. So they were actually gasifying wood somewhere in the back of the car, and then the syngas was brought back to the engine, and the engine was operating. So our concept is really to come up with such a mobile, actually to demonstrate the effectiveness and to collect data of the usability of such a mobile gasification unit that could be operated, and this is the most challenging part of it, on a variety of biomass residues existing in a particular area. Therefore, the issues that we would like to examine will be fuel versatility, the capability of the gasifier to handle a wide variety of feedstocks, and what could be the local logistic management needs. We do have this gasifier. This gasifier was actually developed in the framework of another project, and is a small one in the range of approximately 5 kilowatts only for the time being, electrical output, and something like 20 kilowatts heat output that could also use in parallel. And this will be put into it will be made mobile. It will be put into a container, and then it will start to be moved around. The area that we will focus is in the north of Greece. I hope you can see that this is the north of Greece. Of course, we are based in Thessaloniki, which is the second biggest city in our country, but our target area will be to the west, Aminteon and Ptolemaida, which are two areas which we hope will be supporting us through their organizations to demonstrate the capabilities of our project. The actions or the different tasks that we have, of course, are first of all to build a regional biomass availability profile, which also coupled to the characteristics of the specific areas will lead us to the selection of the particular areas where we're going to go and to run the demonstration part. In parallel, we started already developing and manufacturing the unit. And this demonstration of the unit will start in a year from now and will last for something like 15 months. We will have to operate the unit in 4 different locations for at least 2 weeks per location, constantly, 24 hours a day, which is not a trivial exercise. And then, of course, in parallel, we'll start collecting data, and we have to come up with analysis of the results and sustainability analysis. And of course, in parallel, we have to disseminate the results in the local communities and to see how interesting this approach might be. There are a number of expected benefits. The approach as such is innovative, in particular as regards the fact that it's going to be mobile. We hope that we will help sustainability in rural areas, and such developments can boost or support, if you want, the decentralized energy market potential, and of course, in general, promote the concept and increase the public awareness. I would like also to acknowledge my collaborator, Anastasia Zabagnotou, who is in the same university, and I would like to thank you for your attention.